Yes, so I'll be talking about shallow mantle enrichment beneath the Midcontinental Rift from seismopetrological interpretations. So I wanted to start off by giving some context about what is rifting as well as why we chose the Midcontinental Rift. So for anyone that doesn't know, rifting is just when the lithosphere is being spread apart by extension. So that can happen in the ocean and produce structures such as like mid-ocean ridges, or it can happen on a continental lithosphere and either form a new ocean if it's successful, or if it fails, be frozen in time in the stage of rifting, which it left off, which is exactly what happened with the MCR. So it ended at a pretty late stage in rifting, so it has been outlined via magnetic and gravitational anomaly data seen in figure 2. And then we are looking at composition in this study specifically to see how does it potentially differ within the rift, so directly underneath it, as seen in figure 1 in this black shaded area, and marginally outside of the rift, so 2 degrees outside. So we were looking specifically at magnesium compositions just because from melt that came more deeper in the or more deep in the mantle, the magnesium content tends to be a little bit higher since it is less depleted as when it rises, a lot of that gets depleted as it moves to the surface. Um, yeah, and just as also a side note for this figure 1, this corner has been cut off because it had a really poor seismic resolution. So it's not included in any of our calculations. So any big fans of Central and Western Canada, I'm so sorry. But yeah. And then as for our methods, we started off with the seismic wave speed files for the area surrounding and within the MCR and sorted those into like its according groups. And then we inputted those seismic wave speed files into a toolbox on MATLAB called Wistful, which was able to invert the seismic wave speeds into different compositional properties. So we looked at whole rock compositions through like the database that it has, and different other like compositional properties. So we looked at magnesium. I also looked at aluminum oxide and some other properties like density, but I'll be focusing on magnesium for this project. Yeah. And as for what we found, you can see that in figure 4, at more shallow depth, so at 60 kilometers, there's more of a difference in S-wave velocity as well as magnesium number. So over here, you can, at 60 kilometers, there's about a 0.03 difference in terms of velocity. And then for context, the error is about 0.1 or 0.01. So it is significant. And then as we go at depth, they converge. And the same thing for the magnesium number. And magnesium number is the ratio of magnesium in reference to iron. So at 60 kilometers, there is a difference of about 0.002 with an error of about 0.001. And then that tends to converge as we go at depth again. And then also another side note, in terms of temperature, since the MCR is about like 1.1 billion years old, temperature shouldn't make significant differences for like the composition. So when we're thinking about why these things are happening, we're not thinking as much about temperature, but more about composition. So how does that fit into the whole story? So you can see that the differences in wave speed as well as composition decrease at depth, which is more opposite of what we anticipated. We thought that as we go towards the surface, there would be more depletion and there would be less magnesium richness. So there's different implications for that in terms of how that melt was deposited. If there was like a plume or some type of melt that could have come to the surface more directly, or was it trapped? And in terms of what we saw, we were thinking more that the melt was trapped at around 60 kilometers depth, potentially from a plume, and then enriching that material specifically outside of the rift. Since inside of the rift, that magnesium number tended to be a little bit lower than outside. And I included this figure just to give a little bit more of a visual idea of what could be going on over here. Yeah, but in terms of overall, like the whole story, we think that at a certain depth, most likely at towards the surface, that melt got trapped and then was re-enriched and remobilized and was exhumed outside of the rift rather than where the extension was actually happening. Yeah, but that is it from me. I just want to thank National Science Foundation and Recess for being so supportive, as well as the research or the land that this research was done on. So thank you so much for listening.
Thank you for sharing and presenting. And what I forgot to mention about Kenny is that she's actually a returning recess intern. She did our first recess experience in 2020 when they were all remote. And so we're happy to have you in Boulder and then just back in the program. Ooh, another alumni is here. Zuli, you have a question?
Hi, yes. So, hi, Keneni. So my question would be, how would you like further this research? So I was thinking, so like in my past research internships, well, here at RESESS, we like looked at the mineralogy of it all. So like, I don't know, definitely, I don't know if we can drill down there and get a sample or something like that. I don't know, like that would be like further. But I mean, how would you think to further this research?
Yeah, so I think I'd have to think more broadly about like what I want people to take away from the research as well. I think the mid-continental rift is super interesting, but we actually didn't just do this analysis on the MCR. We did it on like other failed continental rifts in the United States. So like Oklahoma Oclogen and like the Real Foot Rift as well. So I think I would go more of that route to try and make more connections between failed rifts or just passive margins in general versus specifically the MCR, um, as well as maybe looking at more like different compositions. The script that I was the Wistful toolbox, I think had a lot more to offer. I think, yeah, just because using magnesium was an easier way to like think about the things I was trying to visualize, but definitely looking at different chemicals that they offer in terms of like projecting them via the seismic wave speed files. So yeah,
Awesome. Cool. Thank you. Awesome. Great
yeah,
talk.
yeah. Thank you.
Anika, you're muted.
No. Thank you everyone for telling me that I'm muted. It's been 4 years of COVID. I should have known by now. Is there like a data analysis or another tool that you learned this summer that you wanted to learn, or something else that's like a big takeaway from you as far as like research processing?
Definitely coding. I came with some coding experience, but it was really nice to like really like dig into it. This was all on MATLAB, by the way. So this was super like a super good experience for me to just like, better my coding and like making it more efficient in ways that like I usually wouldn't think about because I'm like, oh, if it runs, it runs. But like little simple ways to like make things like make more sense visually, like when I'm coding it and then also like when I come back to it. So all that is really great. Yeah.